Okay, welcome back, and we're in organic chemistry now. So here are the learning objectives for organic chemistry. So, uh, organic chemistry, organic means carbon containing. So, when you hear the word organic, you might be thinking about the FDA definition, where organic is dealing with no synthetic fertilizers or pesticides, where natural ones like arsenic are okay, I guess. But organic chemistry is the chemistry of carbon. And carbon is a very interesting atom, and by the nature, it forms straight chains and then branches those chains. Most of the compounds, single compounds we know, are made of carbon. At least have carbon in the background, in the backbone. So, as I mentioned, carbon, and this is really unique about it. I mean, so if you study the other elements and you work with the other elements, carbon is strange because of this. Forms straight chains and rings. And hydrocarbons, so I say a celebrity Jeopardy question, an easy question in Jeopardy. What two atoms make up hydrocarbons? Hydrogen and carbon. So think about a lot of the vocabulary in science has the answer therein. So hydrocarbons have hydrogen and carbon only. And the simplest hydrocarbons are alkanes. So these are all hydrogen carbon with just single bonds. So simplest being methane, and then the next with two carbons is ethane. So the general formula for all alkanes, at least the not the cyclic ones. So the cyclic ones would break this as carbon to some number, hydrogen to twice that number plus two. So this fits for all alkanes with the exception of cyclic alkanes. And the naming them, use the root word and then for the number and then everything else. So methane is 1, ethane is 2, propane 3, butane 4, pentane 5, hexane 6, heptane 7, octane 8, nonane 9, decane 10. And here are ball and stick models. So here is the ball and stick model for propane. So stuff that at least I use in my grill. And sometimes we condense the structural formula to make it easier to write, like down on a piece of paper. So propane, although can be represented this way, can also be represented as CH3, CH2, CH3. And here are the rest of the alkanes. So and there's the condensed structural formula, and so isomerization, so the number of possible isomers. Isomers means the same number and type of atom, but different connectivity. So methane, ethane, and propane, there's only one way to write them. But butane, you can take this carbon and you can hit it on the side. So that's called the isobutane, for instance. And okay, I already mentioned isomerism there. So there's butane. You can move that one over like I showed in the structural formula. So you have isobutane. And here are some physical properties of the octanes. Well, alkanes, sorry, excuse me. I was looking at octane. So, and you can see what we use most of them for is for fuel. And so we use natural gas. So, well, here, ethane, we use it plastics. More importantly is ethene, the double bond, for that's the most common plastic. We'll talk about plastics more later. Propane we use for burning like in gas grills. And the next series are gasoline. Gasoline we tend to gear towards the octanes though. But if you look at the melting point for these, so octane can freeze at around negative 60 Celsius frequently. So you can add things like hexane to your gasoline. That's to prevent what's called fuel line freeze up. I know this is something you don't have to worry about too much in Hawaii, but in really cold places like Alaska and the Arctic and Antarctic, you do have to worry about fuel line freeze up. Actually, if you've traveled there, I remember I went to Alaska in the winter. You had to plug in your car. Besides the fact that you couldn't start the engine, they had to keep the viscosity of the fuel of the oil from preventing the engine from freezing that way, literally freezing. Okay, and then so low the light. We hydrocarbons use natural gases, and we use those for to heat the homes. Not in Hawaii, but else in the mainland. Then propane we use to grill food. Then the liquefied, like the petroleum and pentane, we can use like the butane lighters. You can use butane in lighters and some in gasoline. Then we go to diesel fuel. Also, jet fuel is also in the same range as diesel fuel. So diesel and jet fuel like to use these long single chained hydrocarbons. Gasoline we prefer branched and cyclic for gasoline, and then for the longer ones we use for paraffin wax and also for roads for asphalt. So if you ever look on the roads at the roads especially in the bus lanes, you'll see that sometimes the asphalt is pushed to one side because it's the bottom part of the distillation column. That's we're using hydrocarbons, and it's has a viscosity. So if you push on it, it will creep. It'll deform. So I mentioned cyclic hydrocarbons. Uh, Carbon can also form cyclic rings. Cyclopropane, so three carbons. This is the simplest of it right there. So cyclohexane and these that's for six. So the name these you have the cyclo plus then the root name of the hydrocarbon there. So hexane is six carbons. If it's cyclized, cyclohexane. Okay, alkenes. So we talk about alkanes, also known as saturated. Saturated means all single bonds. So if you heard of saturated fats, those are single fats that have only single bonds. Alkenes are also known as unsaturated, so they have one or more double bonds. And alkene, at least not the cyclized ones, but the general formula is carbon to the n, hydrogen to some number 2n. And this is for a single ene. If you have more than one double bond, you will lose more hydrogens in that. So ethylene is the simplest alkene. Ethylene is interesting. Uh, it smells like rotten bananas. That's the smell that I get. If you ever let fruit and vegetables sit for a while, you might notice the smell that comes up. The smell, among other things, is ethylene. Ethylene is autocatalytic in forms of fruit ripening. So, meaning that when fruit ripens, it releases ethylene, and the ethylene causes the fruit to ripen more quickly. So, maybe you've heard some of the old phrases like a bad apple will spoil the whole bunch. Well, that bad apple is releasing ethylene, will cause the other apples to ripen faster and rot faster. So, that's kind of a true term there. Uh, Sometimes ethylene is used to treat fruits and vegetables. Like, have you ever had a banana that looks perfect on the outside, nice and yellow, and you open it up, it's all kind of green and raw on the inside? You're like, what happened here? It's because it was treated with ethylene. This that's a sneaky way to do it, but also some containers will have holes in them so that you put your vegetables in there, so that way the ethylene can escape. So if you wonder why when you buy like grapes at the store, or some bags they have a plastic mesh instead of a plastic bag. Why is the point of this mesh? It's to let ethylene escape. But ethylene is important because it's used to make plastics, specifically polyethylene. So many ethylenes. So although ethylene is the common name, ethene is the formal name. So it depends on the state and country's laws, but if you ever go by a distillation column, sometimes you'll see flames shooting out the top of them. What they're doing there, they're burning the ethylene. It's just like, we don't really need this. We're just going to burn it. So, of course, we took that byproduct and we make plastic from it. So, and plastic is very useful. Although I know plastic is certainly going out of style, single-use plastics are going out of style, but plastics are very, very useful. We use them for many things. We'll talk about that more later. Okay, so alkyne is a triple bond, one or more triple bonds, and there aren't too many alkynes. Besides acetylene or ethyne, they tend to be relatively unstable. But acetylene, this is used in welding torches, so and it can burn things very, very hot. So yne is the word for this. So uh, acetylene ethyne is the simplest alkyne, and we don't see these as frequently. You can see them. You can see a triple bond in some fats, but in general, though, there tends not to be too many triple bonded carbons. So let's go back to alkanes and cis and trans isomerization. So maybe you've heard of trans fatty acids, and all fats made by all plants and all animals in nature here at Earth have cis isomerization. Cis is on the left, where you have the functional groups on the same side. Trans is actually more energy favorable. That's on the right. So that's the cis and trans isomerization. It changes some of the physical properties of the uh, molecule in question. And like I said, natural fats are all cis, where we see some trans when we hydrogenate oils. And benzene is a special type called aromatic. It's originally called aromatic because it smells. It smells pretty good, actually. Benzene, I don't know about benzene, but some of the other molecules smell good. I like toluene. Toluene smells good. But we sort of call them aromatic because they have special properties. As stability is what those are. And so here's benzene, and the question is, which one? Where do we put the double bond? Do we put it here, here, or there? It turns out that they both work, and the electron cloud actually forms kind of a donut around the molecule. So this blending of the bonding turns out to make it really relatively stable. And here are some of the aromatic ones. Toluene. This stuff smells great. It's really sweet smelling molecule. I don't know what ethylbenzene smells like, but naphthalene. Oh, I hate naphthalene. It's mothballs. So they put naphthalene in mothballs, and I hate that smell. It gives me a headache after a while. I can't tell the difference between the xylene. Xylenes all smells like gasoline to me, but you can separate them by distillation there. The ortho position. It's just, if you notice here, you have the ortho is right next to each other. The meta is one over on the ring, and the para is opposite. And that circle, so that hexagon with a circle, that's a benzene ring. So that implies that's the same thing as this, but the circle there shows that it's a blended bond series. So if you see that, that just means an alternating single double bond that kind of blends together. So also hydrocarbons, you can chlorinate them. So some of them have useful properties. Much of it use has been banned. Chlorinated hydrocarbons originally they're good for anti-fire agents. So because chlorinated hydrocarbons char very quickly, but they're pretty toxic, so we stopped using them. Chloromethane, dichloromethane, also known as methylene chloride. This stuff, it's a very, very powerful solvent, and it smells bad. Chloroform is also a solvent, but it was originally used as an anesthetic. So, in the Civil War, especially, they would use chloroform to knock people out. We tend not to do this anymore. Why we don't use chloroform as an anesthetic anymore? Because the um, the toxic dose is very close to the therapeutic dose. So we tend to use more narcotics for for surgery now. And then, so for for carbons, here's another celebrity Jeopardy question. What three elements are in chlorofluorocarbons? Chlorine, fluorine, carbons. Due to ozone depletion, we tend not to use these as much anymore. We've been switching to chlorofluorohydrocarbons. I'm sorry, fluorohydrocarbons. We try not to use the chlorine. The fluorohydrocarbons tend to be what we've been using more frequently now for as a replacement for the CFCs. So functional groups. So with organic chemistry, we look at the groups. So you have the carbon chain, and then the carbon. If it's just carbon and hydrogen, then we can. If it's all single bond, it's an alkane. If it has one or more double bond, it's an alkene. If it has one or more triple bond, it's an alkyne. And it's in order. So let's say it has a double and a triple bond, we'll call it an alkyne. So, but then we can add functional groups to this, like an OH group, and then we call it an alcohol. So now we start to categorize the organic compounds based off of what groups are on them, and then that changes their chemistry. So I already mentioned to alkane, alkene, alkyne. Alcohol has the OH group on it. And notice that we have this R. The R means hydrocarbon. So R is a hydrocarbon. Just to make it easier to write that. And so the R single bonded OH, the OH is the alcohol group. And so lots and lots of alcohol, of course, familiar mostly with methanol and ethanol. But certain things like cholesterol is an alcohol, it's a steroidal alcohol. Moving on to ether, ether's general formula is you have a hydrocarbon attached to an oxygen attached to another hydrocarbon. Most common ether is, of course, diethyl ether, or the original ether. Aldehydes, it's the end of the molecule has this carbon double bonded O and then an H. So aldehyde there, and these tend to smell pretty strongly. Ketones, these smell pretty strongly and sometimes smell pretty good, except for acetone. I hate acetone. General formula for a ketone is is a hydrocarbon attached to a carbon with a double bond O attached to another carbon. So maybe you've heard of something called ketosis. That is when our body is in starvation, we go to a state of ketosis or ketoacidosis. That's where there are ketones found in the blood. And then the carboxylic acid group at the end, you have the acid group at the end, the C double bond OH. That makes it into a carboxylic acid. If you, instead of a hydrogen in the carboxylic acid, if you have another hydrocarbon, that's known as an ester. And an ester, these tend to be these are the ones that smell great. I really like the way these things smell, and most everyone likes the way they smell. They primarily used for flavors and fragrances. And amine, this is an organic compound, a carbon-containing compound that has a nitrogen in it. So those are amines. So we'll talk about amines at the end of the lecture. And amides. Proteins are amides. It's when you have the C double bond O attached to an end. So proteins and amino acids. So those are, proteins are the polyamide bonds. So you have the amide linkage there. Okay. So here are the alkyl group. These are the R groups. So methyl is the common, then you have ethyl, here's propyl, and then here you can have isopropyl. So it's the isomer of the propyl. And butyl and sec-butyl is another one here, so just having the secondary carbon there. And you can have isobutyl, and then last one being tert-butyl. Don't have to worry about these too much at this level. Okay, alcohols has the OH functional group. So methanol is very common. This is known as wood alcohol. And ethanol, very common, used also known as grain alcohol. Ethanol is the stuff that you drink in alcoholic beverages. And then propanol, this is 1-propanol, but you're probably more familiar with 2-propanol, also known as isopropanol. That is the common alcohol used in rubbing alcohol. So isopropyl, IPA, isopropanol. Methanol is pretty toxic. You ingest a little bit of it, it can cause blindness. Of course, the cure for methanol poisoning is to drink a large amount of ethanol. Ethanol is well, say it's safe. It's relatively safe, but ethanol is toxic. It's and you can get alcohol poisoning from ethanol. And the poisoning is actually not from ethanol. It's the your body turns it into acetaldehyde. So alcohol poisoning should be called acetaldehyde poisoning, but we typically call it the alcohol poisoning. Propanol, you don't want to drink the stuff either. I've never drank methanol or ethanol, at least, or methanol or propanol, at least in large quantities. Uh, Methanol can cause blindness, like I said, and propanol, just nasty hangover. And it's called wood alcohol. Methanol is sometimes called wood alcohol. One of if you take wood and you heat it in the absence of oxygen, you can get it is called pyrolysis, and one of the components of that is methanol. Also, if in making of whiskeys and other distilled products, you typically throw away the top portion of the stuff that comes off the distillation column first. The reason for that is because it tends to have more methanol in it, and we can this if you get water in your gasoline, you use that as a fuel additive. It'll take up water that's stuck in your gas tank. It probably won't be used as a fuel replacement. It just doesn't have enough energy. Methyl alcohol has about 40% the energy of gasoline, and that's just, and it's also super toxic. So we tend not. So methanol is not going to be a fuel replacement. I disagree with the book on this. So ethanol is grain alcohol, and it's already added to gasoline. We have 10% added to gasoline in Hawaii. Many other places added up to 10%. What's so special about 10%? That's well, especially maybe 20%. The ethanol can dissolve the lines in your car. So like an E85 car, that's 85% ethanol. The only difference between the car and a normal car is that the tubes carrying the fuel is different. So that way it can handle the dissolving nature of the ethanol. And so methanol is very toxic. It'll your same enzyme alcohol dehydrogenases will turn methanol into formaldehyde. Will turn it into formic acid, and then that attacks the optic nerve. The same for ethanol, but our bodies can take a lot more ethanol than the other alcohols. And as far as species are concerned, humans can handle a lot of ethanol. We've in some ways you could say we evolved to drink. So we I don't mean that in terms of like it necessarily that's our primary source of evolution, but we historically have consumed much alcohol, and humans can handle it better than other animals. So if you do give alcohol to your pets, they will not be able to handle as much alcohol as humans can. So here are some as a chart that shows the effects of ethanol, and of course this depends on the person. So some people, especially of the mongoloid type of person, that's the Asian basically. The that's it can happen to anyone, of course, though, that the amount of alcohol dehydrogenases that are produced, it can be less, and there's a genetic predisposition for mongoloid humans to have less of that. But it just, of course, it depends on the person and their family history or the genetics. But there are certain people that can get drunk off of very little alcohol. And some people can drink much more relative to other people. So it just depends on the person. I do not recommend you try that experiment, of course. So there are polyols, so many alcohols. So ethylene glycol, that's what's used in antifreeze, is a diol. Propylene glycol, this is used as a heat transfer medium. Also, both ethylene glycol and propylene glycol used to de-ice planes. Propylene glycol is used more commonly in Europe, ethylene glycol more frequently in the United States. Glycerol, also known as glycerin, this can be used as a lubricant and as a humectant. Humectant is something that gathers water. So, for instance, if you get the drops you put in your ears, it contains isopropyl alcohol, 95%, and about 5% glycerol. And the idea is that the glycerol will draw the water out of your ears, and the isopropyl alcohol will evaporate and bring everything out of the ears. So, if you wondered how those eardrops work, they can put glycerin in soaps and shampoos as well to add to it'll draw water to it. And glycerol you can eat. Propylene glycol, you shouldn't drink ethylene glycol. You can consume propylene glycol. It's If you are of the legal drinking age, they put propylene glycol in the Fireball whiskey, and there's some controversy because Europe says we use it to de-ice our planes. We shouldn't put it in alcoholic beverages. The truth of the matter is it's fairly non-toxic, and the cure for propylene glycol poisoning is to consume large amounts of ethanol. So the bottle contains both the poison and the cure, so uh, it's not really that bad for you. Uh, okay, so moving on, phenols. Phenols are aromatic compounds that have OH on them. It's an alcohol. So phenol is an aromatic alcohol, and but they're because of the aromatic ring, they're more like acids than they are alcohols, and they're primarily used to as an antiseptic to so you can there's phenols and so if the stuff that you spray in your mouth, Chloraseptic I think is the brand name, but they to get rid of like canker sores and that kind of stuff, that's got some phenols in it, and can be used to sterilize like surgical equipment. Ethers, we primarily use these as solvents. And so we have uh, a hydrocarbon, oxygen bonded to another hydrocarbon. And diethyl ether is the more famous one. So if you hear ether, usually you mean diethyl ether. This was originally used as a drug, and this was the original anesthetic. It was discovered by a dentist. So if you remember, well, back in the day, surgery. I mean, surgery is still a scary ordeal. But he was a dentist, and people went to an ether party because it was fun, and he got high off of the ether, and he's like, you know what? I could use this on my patients, and they won't care if I'm ripping their teeth out because when they're high. So he's the one that actually started the idea of doing it as a dentist. I mean, before that, it was if you've heard the term "bite the bullet," like we're gonna operate on you. So here, instead of scream, just bite the bullet. Because bullets were made of lead, and they were kind of soft, or they give you a stick to bite on, so you can just, while you're in pain, just bite onto this and hold still as I'm doing operations on you. So nowadays, of course, we tend to use anesthesia to make it easier on both the surgeon and on the patient. So, but ethers are these are used primarily as solvents. And one thing about ethers, though, they especially in sunlight and whatnot, they can form so peroxides, which tend to be explosive. So be careful about old containers that have ether written on them. Um, don't pick them up and shake them because they might explode. So another ether, ethylene oxide, also known as epoxide. is a common one, and we use this to improve the ethylene oxide is used to improve the quality of certain surfactants. So and if you've for soaps, and we can use it to make ethylene glycol, for instance. So aldehydes has the N group, so it has a hydrocarbon with a C double bond O, then an H attached to it. That's with just the H is an aldehyde with another hydrocarbon that's known as a ketone. Aldehydes, they can be used as solvents. They also use them as fragrances in some things, especially laundry detergents have a lot of aldehydes in them, and at least it's for fragrance. And the ketone, so I always think of acetone as a simple ketone. And ketones also used as solvents, and our body makes them with the ketoacidosis. So here is formaldehyde in A. That's formaldehyde. Can be used in hair products. We don't use it anymore. Then the next one is acetaldehyde. Acetaldehyde has a green apple sort of flavor to it, and it's put actually intentionally in some beers. I won't mention any names, but the king perhaps might have a word to say that. Has a green apple flavor. It's also what our body can turn alcohol into in the step, and that's what causes alcohol poisoning. Then next one is going over is acetone, or 2-propanone is the proper name for it. So propanone, 2-propanone, or acetone there. It's also used as a solvent. So having the end is that carboxylic group. The carboxyl group makes the organic compound a carboxylic acid, and or also sometimes referred to as a fatty acid if the carbon chain is long enough. And here is benzoic acid. So if you have maybe you've seen a common preservative sodium benzoate. Here is the benzoic acid. Here's the acid of that. And esters. So if you have a carboxylic acid, and you can see I'm really blowing through all these different things. There is a whole 2-semester course associated with this. I'm just giving you a really brief overview, so don't freak out as you're doing this. But if you have a carboxylic acid and replace the hydrogen with a hydrocarbon, then you get an ester. And these are fun. These smell great. So and you can use them like the artificial flavorings. So this is what they are. So I'm looking down here. I see the methobenzoate going down. I don't think that really smells like kiwi. It smells more like bananas to me. But that's just for my own personal, I guess, opinion. Ooh, methyl salicylate. I like that stuff. Wintergreen oil can be used as a lubricant too. It's funny thing. Methyl salicylate, they use that as a lubricant in nuclear submarines, for instance. But so that's nice that the lubricant smells good. I hate the smell of lithium grease, but I like the smell of wintergreen oil. And they put wintergreen oil in certain. I mean, you can eat it as well. So, but and the O in front of that just means ortho. That's a position on the benzene ring there, the aromatic ring. And okay, so then you can see there's different flavors there, and they're from these esters. So, because a lot of chemistry can smell really bad. Excuse me, chemistry can smell really badly. This stuff smells great though, tastes good. And the name you draw, the way that you name these, you start with the name of the alcohol, and then followed by the root name of the acid, and then drop the E and add the O8. So so you take methanol, start with the name of the alcohol, so it's methyl, and then the butyric acid, the 4-carbon acid. So this is methyl butanoate. Okay, moving on. Went from really wonderful smelling stuff to amines. Amines are really smelly. They tend to be really smelly, and so you can see here you have an amine. So then you have So start with ammonia, and then if you add a carbon to it, you have a primary amine. You add two carbons to two different carbon groups. You have a secondary amine, and three carbon groups. You have a tertiary amine, and you can add another one, and you can get a quaternary ammonium salt, and also sometimes referred to as quat. Quaternary ammonium salts, those are used as for they can use them for conditioners, and also for for antimicrobial action. So the cleansing wipes that you get, like the bleach wipes, those don't actually have bleach in them. They have quaternary ammonium salts. They started using that. They sprayed it on food processing equipment. So especially like butcher shops would spray it on that there, and then they started using that for for cleansing, like in the bathroom and whatnot. Uh, Dryer sheets use that too because adding positive charge to things, especially natural natural fabrics, will make them softer, and the hair too. So dryer sheets actually can also kill more bacteria. So okay, and yeah, they have terrible smells. Oh man, I remember smelling trimethylamine. Stuff smells like dead fish that's been sitting in a closet for 2 months. Stuff still smells terrible. So let's talk about other amines. And you can see here you have amphetamine. Now, when you see these words, you'll start to associate them, and maybe even you can hear the word vitamin. Vitamin used to be vital amines, but it turns out they're not. There's some of them are amines, but they're not all amines. But The name stuck, and instead of calling them vital amines, we say vitamins. We say it quickly, so it doesn't, so we can confuse ourselves to not thinking that they're actually amines. So amphetamine, of course, this amphetamine has a psychotropic action on humans, and so when you hear like methamphetamine, for instance, there's just a methyl group attached to that. And you can see some of the other like cadaverine. It smells like cadavers. When animals are decomposing, they release cadaverine, and not a very good smelling thing. So amines, I hate the smell of amines. They're stinky. And if you have these, you can attach a carboxylic acid group. You can with a C double bond. You can attach to a not to an amine to get an amide, and if you have many of them, it's a polyamide. That is what a protein is. Also, so nylons are also polyamides. We'll talk more about that later, but this is important because this is how our body gets its structure, is through its polyamide bonds. And heterocyclic contain atoms other than carbon in its ring. So uh, many of them contain nitrogen, oxygen, or sulfur. I've already looked at epoxide before. Epoxide has a heterocyclic that has oxygen in it, uh, but many of them have nitrogen, and those are known as alkaloids. So we have the amines that have the alkali that have the nitrogen in them. Uh, these Many of these have physiological effects. So morphine, caffeine, nicotine, cocaine, these are all alkaloids. But that doesn't mean that every single alkaloid has a psychotropic effect. So all the nitrogen bases found in DNA, adenine, thymine, cytosine, guanine, and uracil, these are all alkaloids. So it's not like all alkaloids are drugs. No, that's not true at all. But the we're familiar with the common ones like caffeine and nicotine. We know those. We're familiar. Many people tend to be familiar with those molecules. So, and we are at the end. So again, caution. This is just a brief overview of organic chemistry. I mean, this has just been an hour-long talk. You do not have to know everything in this chapter, just in the general stuff. And this is a overview and introduction to it. So you don't have to know everything in great, awesome detail. that's been in this lecture. So, oh, it's been an hour. It's been 40 minutes.